Hey Algebra. In this lesson we're going to talk about how to use the factoring skills we learned in the last 4 lessons to solve equations involving quadratics. When we say solve, that means we're finding solutions. If you remember, back when we were graphing, if I were to ask you to solve an equation, you would find where it would cross the x-axis. No matter what the equation is, where it crosses the x-axis is your solution. Now we're going to use the zero product property to do that. So first of all, let's look at this equation. A times B times C times D equals 0. What values of A, B, C, and D would make the equation true? Well, if this multiplication equals 0, that means that any of those variables could be 0. A could be 0 because 0 times B times C times D does in fact equal 0. Well, B could be 0 also because A times 0 times C times D equals 0. If I put that 0 anywhere in that equation, it wipes out the whole equation and makes the whole thing equal to 0. So C could be equal to 0 and D could be equal to 0. So we really say A equals 0 or B equals 0 or C equals 0 or D equals 0. Alright, let's try a few. So we learned it, now we practice it, right? Find the values of C and D that satisfy each of the following equations. There may be more than one correct answer. So if C times D equals 0, that means that C or D must be 0. They could both be 0 at the same time. You can also assume that. Okay, with this next one, there are actually a ton of different correct combinations for C and D. Infinite. You can give me any answers as long as they work together. If we pick something for C, we have to pick only one thing for D, etc. So let's just think about it. If I say, let's say if I say D were equal to 2, if D were equal to 2, I can solve this. I'm going to distribute that 2 first. Add 10 to both sides is 12. 2C equals to 12, so C equals 6. And D equals 2. We could try something else. Just, like I said, there's an infinite number of solutions. Let's say if, I don't know, C equals 5. I'm going to plug that in. 5 minus 5 times D equals 2. 0 times D equals 2. D would be equal to 0. Just another solution. Infinite answers on that one. We're just solving the equation that we see. Okay, same equation but set equal to 0. Since the product of those two terms, well, here we have a binomial, and there we have a term, the product of those two has to be 0. There aren't infinite number of solutions. What we do here is we take each piece, we take the binomial, because this part could be equal to 0, or that part is equal to 0. So let's solve each one. Add 5 to both sides. C is equal to 5. And this one's already solved. So we have two solutions. C equals 5 and D equals 0. D could actually be anything when C equals 5. Okay, we're getting just a little bit more complicated. Here I have two binomials now. Our product property rule holds. So this could be 0, or that could be 0 to get 0 for an answer. So we take each binomial and set it equal to 0 and find out what the variable is. So add 5 to both sides. I have C equals 5. Minus 3 from both sides. D equals minus 3. Each one of these makes the equation a true statement. Okay? So here I can say they can both be true, or just one can be true. Both of them don't have to be true. At least one has to be true. Right, example. So let's read through this. For each of the related questions below, use what you know about the zero product property to find the answers. The area of a rectangle can be represented by the expression x squared plus 2x minus 3. If the dimensions of the triangle are known to be the linear factors of the expression, write each dimension of this rectangle as a binomial. Write the area in terms of the product of two binomials. So we're factoring this. That's all they're telling us to do. Okay, so we're going to take that equation. A times C is negative 3, which splits into 1 times 3. And if I add them together, I get a positive 2. So that 1 has to be negative. So my binomial is x minus 1, x plus 3 equals, well, that's just a binomial, sorry. That's my area. That's what they say, the area in terms of the product of two binomials. So binomials are two terms in a parenthesis and they're multiplied together. Yep, I think I did everything right there. So my dimensions of my rectangle, I have x plus 3 and x minus 1. Oops, I didn't read on, I'm sorry. I would make my longer side, just like I did above, is the x plus 3, and the shorter side is the x minus 1, with the area x squared plus 2x minus 3. I can actually draw that in a really fun way. If we say that's x, we can say that this is x minus 1. And let's see, get about the same size. If that is x, we can say that the whole side is x plus 3, with this being 1, 2, 3, that being 1. Pretty cool. Alright, now let's suppose the rectangle's area is 21 square units. Can you find the dimensions of the rectangle? Yeah, of course I can. I have x plus 3. I'm going to put it in factored form. Equals 21. Or I could say that x squared, what's the original equation? Plus 2x minus 3 equals 21. So part D says rewrite the equation so it's equal to 0 and solve. I'm going to go right here, subtract 21 from both sides, and I have x squared plus 2x minus 24 equals 0. Now I have to factor it again, which is fine. Negative 24 breaks into, let's see, 2 times 12 doesn't work. 3 times 8. Ooh, 4 times 6. I have a negative 24 and a positive 2, so I'm going to do that. So my factors are x minus 4, x plus 6 equals 0. So to continue to solve this, this is our zero product property rule. I take each one of these binomials and set it equal to 0 to figure out what the possible values of x make that a true statement. So x minus 4 equals 0. Add 4 to both sides. I have x equals 4. Makes that a true statement. X plus 6 equals 0. Subtract 6 from both sides. X equals negative 6. So we have our answers, our solutions. So what are the actual dimensions of the rectangle? So we gave the dimensions of the rectangle early on in this problem as x plus 3 and x minus 1. Well, we just solved that x equals 4 or negative 6. So let's go ahead and mess with that a little bit. I've got 4 minus 1 is 3. 4 plus 3 is 7. It would be a 3 by 7 rectangle. Length and width. What about that negative 6? What do we do there? Well, these are dimensions. I cannot have a negative value because I can't measure a negative value. My ruler doesn't go negative, right? So that one is dismissed. All right, a smaller rectangle can fit inside the first rectangle, and it has an area that can be represented by this quadratic. If the dimensions of the rectangle are known to be the linear factors of the expression, what are the dimensions of the smaller rectangle in terms of x? This is another way to figure out the binomials. Linear means that we have x to the first power So I have, if the dimensions of the rectangle are known to be the linear factors of the expression, here we have the linear factors of the expression. This right here, if I graphed it, would be a line. That would be another line. Okay, so in the last problem it said the product of the binomials. In this problem it's saying the linear factors of the expression. So I know I need to factor this. So I have negative 5 breaks into negative 1 times 5. That's not going to work. I need a negative 4. So 1 times negative 5, if I add that together, I get a negative 4. So my linear factors are x plus 1, x minus 5. So we have to learn this terminology. What values of x would make the smaller rectangle have an area of 1/3 of the larger? Well, that first area was 21. So 1/3 of that is going to be 7. So we need this rectangle to have an area of 7. It's actually easier to go straight from the quadratic. So subtract 7 from both sides. I have x squared minus 4x minus 12 equals 0. Negative 12 splits into 1 times 12, 2 times 6. Oh, I need a negative 4, so there we go. So x plus 2, x minus 6 equals 0. Solve each binomial, solve each linear factor. So x is going to be negative 2 or 6. Remember, these are real life problems, so I cannot measure something that's negative. So x in this case is going to be 6. That is my dimension. So if I put that back into my original problem, where I had, x minus 5 and x plus 1 were my original dimensions. If I put in 6 there, I'm going to get 6 minus 5, which is 1. 6 plus 1, which is 7. These are the dimensions of my rectangle. It's a 1 by 7. Alright, let's practice a few. Solve, show your work. So we need to set these equal to 0. I don't know why I wrote 6. Plus 5 to both sides, I get x squared minus 11x plus 24 equals 0. That 24 breaks into, I need to get a negative 11, so 1 times 24, 2 times 12. That's not going to work. I want that to work, but it doesn't. 3 times 8, 8, 9, 10, oh, there we go. So we have x plus 3 times x plus 8 equals 0. Set each of those binomials equal to 0 and solve. X equals negative 3 or x equals negative 8. Ooh, mistake. These should both be negative, which gives me a negative 11. Let's see, how can I correct this? You can learn from my mistakes, right? So that should be a negative, that should be a negative, 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 positive, positive. So my answer is 3 or 8. Alright, here, this one is an easier one. Just look for your common factor and factor it out. I have an x, which leaves me with 7x plus 1 equals 0. I set this equal to 0, and I set that equal to 0. X equals 0, or 7x plus 1 equals 0. This gives me, subtract 1 from both sides, and divide both sides by 7. So my answer is x equals 0, or x equals negative 1/7. Okay, we need to get it equal to 0, so add 7 to both sides, and I have 7r squared minus 14r plus 7 equals 0. Now here I have a trinomial, or a quadratic, where I can factor something out of each term. So 7r squared minus 2r plus 1 equals 0. So 1 can only factor into 1 times 1, but I need a negative 2 in there. So negative 1 times negative 1 is positive 1. Negative 1 plus negative 1 is negative 2. So I have r minus 1 times r minus 1 equals 0. Set each of these binomials equal to 0. They're the same thing, so it's sort of easy. So r equals 1 or r equals 1. Now, what happens to this guy that we factored out? Well, what I could show you in the beginning, let's go back up a little bit. I've got a 7 out there with my trinomial. I just ignore the 7, but what I'm really doing is dividing both sides by 7, which gives me r squared minus 2r plus 1 equals 0. The 7 is irrelevant. It divides out, so life is grand. Cool? Alright, let's try this last one. Can't factor anything out, so I have a negative 24. And I need a positive 5 in the middle. I think that's going to be my 3 times 8. 3 times 8, it's a positive 5, so that's negative, which gives me a 5. I'm not going to have enough room on this one. Minus 3d plus 8d minus 12 equals 0. Factor by grouping, just like we've been doing. I can take a d out of this first one. I'm left with 2d minus 3. I can take a 4 out of that one. I'm left with d minus 3 equals 0. Oh, 2. Whew. 2d minus 3 times d plus 4 equals 0. This first binomial, set it equal to 0. 2d minus 3 equals 0. Add 3 to both sides. 2d equals 3. Divide both sides by 2. d equals 3 halves. Then I have d plus 4 equals 0. Subtract 4 from both sides. d equals negative 4. That's it. That last one was a good one to end on. Our zero product property rule. If you're trying to solve an equation, rewrite it in factored form and set equal to 0. Using that zero product property, you know that if one factor is equal to 0, then the product of all the factors is equal to 0. Cool? Good work.